Hello PyCon! My name is Jon Crall and today I'm here to talk about developing with doc tests. I'm going to talk about what doc tests are, why you should care about them, and how you can better utilize them using a package that I wrote called Xdoctest. Before we get into it, let me give a quick personal introduction. My name is Jon Crall. You can find me online at Aerotemic. I have a PhD in computer vision and I'm currently working at a company called Kitware. In addition to mathematics, deep learning, computer vision-y sort of things, I'm also interested in test-driven design in the Python programming language, which is why I wrote the package Xdoctest that I'm here to talk to you about today. So before we talk about Xdoctest, let's just talk about doc tests. So what are doc tests? If you're familiar with Python, you probably know how to write a function. And you also probably know that if you put a string directly after a function, that's a docstring. In a docstring, you can put any sort of documentation that you want. So one really useful thing to do is to demonstrate how to use the function that you've written. So you can put some code in here, and if you prefix that code with 3 chevrons and a space, that's a doc test. I've highlighted the doc test in this example. You can see that we create some demo inputs, we show how to pass those inputs to the function itself, and we assert that the output looks reasonable. In addition to helping new developers learn how to use your code, if you can extract this code and test it in your continuous integration suite, you can not only increase your coverage, but be more confident that the code that you've written is correct. So what else can doc tests do? How do you develop with doc tests? Well, as an example, whenever I write a class, I like to create a class method called demo before I write any of the functionality. And I might call this demo data or random depending on the circumstance. But the basic idea is I want to create an example of the inputs that I'm interested in manipulating. I then open IPython, create instances of these inputs, and I start playing with them. And as I'm playing with them, I eventually converge upon the functionality that I'm interested in implementing. But that's not the only thing that I've been doing in IPython. I've also been writing checks to make sure things are going as I expect them to. So instead of just exiting IPython and letting all those checks go to waste, why not also copy those back into the source file? And what better place to put them than inside a doc test? This means that as a natural byproduct of the development cycle, you've not only written the functionality that you're interested in, but the tests for it as well. And the tests, this is key, are coupled with the code. This means that if you have to refactor your module, move it from one package to another, the tests always come with it. Additionally, when you develop with doc test, you get entry points everywhere where you have a doc test. A doc test always allows you a way to create the inputs that you need so you can step through a piece of code line by line without any other prerequisites. This is very useful if you have a long-running stack of code that might error, perhaps in a function that has a doc test. Instead of rerunning that code, perhaps you can use the demo inputs in it to reproduce that error and perhaps fix it without having to rerun that long-running stack too many times. So now that we know what a doc test is and how you might develop with doc tests, let's talk about specifically how to write a doc test and, most importantly, how to run them. First, to write a doc test, you simply have a function and you write a test for the function. Then you prefix your test with 3 chevrons and a space, and then you simply insert this block of text into the function docstring. And with some minor exceptions, that's essentially all you need to do to write a doc test. Now, to actually run a doc test, it's a little trickier. And to go over why that is, I want to talk about a few case studies. So as a first case study, I want to talk about this function paragraph. The idea of this function is we're going to take in a block of text and we're going to just remove all the extra new lines and spaces. And then we're going to return the output. So to test this, let's create some input text. Let's use the triple quotes, which means the text will be filled with extra new lines and spaces that we might not want. Let's pass the text through paragraph, get the output, and then we can assert that there is a new line character in the original text, but there is not a new line character in the output text. Seems like a reasonable test. So let's create this as a doc test. We'll make a file, talk.py. I'll put the function in the file, and then I will insert the doc test into the docstring. I'll prefix with the appropriate 3 chevrons, and let's use the built-in Python doctest module to run this. That's right, Python actually ships with a doctest module. To run the main block of this doctest module, we can use python-m. -m means run the main block of a module. And as an argument, we'll give it the file that we want to run the doc tests in. This will run all the doc tests in the file. So let's do this. Let's see what we get. Errors. What happened? I thought the test looked pretty reasonable. There didn't seem to be any syntax errors in there. What's going on? It says we have a syntax error. There's an unexpected end of file while parsing. Well, what happened is that doc tests can't handle multi-line statements without help. We can fix this by taking all of the extra lines after a multi-line statement and replacing the first 3 chevrons with ... If we rerun the doctest module with this new edited test, we see that it works. It's a little annoying that we have to tell Python how to parse its own code, but we got there. So let's go over another case study. This time, let's look at the function allSame. The idea is we're going to take in an iterable, and we're going to determine if all the items in the iterable are the same. We're going to use a feature of doc tests that I haven't talked about. If you execute a function and it returns a value, you can actually, in the next line, give a string representation of the value that you expect to get. I'm going to call this a got-want string. You got something by calling this function, and you want something by passing it a string here. So if we run allSame on 1, 1, 1, 1, we expect to get true. AllSame on an empty list, we also expect to get true. 1 and 0, they're definitely not the same, so false. Let's make sure that it works on iterables. We can create an iterable that do not have the same elements. We can pop off the first one and then check to make sure that it works on the rest of them. 1, 1, 1 should be the same, so true, and so on. So let's take this doc test, put it in our talk.py file, and let's run the doc test using the built-in Python doctest module. There's no multi-line statements, so this seems like it would work, right? Errors, again. All right, what happened? Let's see, we failed on the next iterable line. We expected nothing, but we got 0. Well, if you remember, we popped off the first element of that iterable because we wanted to test iterables, and we didn't give it something to expect. Because we didn't give it something and we got something, the built-in doctest module is going to error because it forces you to put values in for anything that you want. So, okay, we can fix this. We can fix this actually using another feature of doctest that I haven't talked about yet, directives. By putting a comment with doctest : plus ellipses at the end of this line, we enable the ellipses feature of doctest. That means if we give it a ... that will match anything that comes out of this statement. This will effectively prevent us from needing to care about what's going on here because for the purposes of the test, we don't. So if we rerun this again, this will work. Well, at least I thought it would work. It turns out it actually doesn't, but let's just skip ahead because running doc tests seems to be harder than it needs to be. So I want to pose a question. Why aren't doc tests everywhere? They seem really useful, but as we saw, they're kind of tricky to run. And you sort of do see them a lot in the wild, but the issue with them is a lot of times the code that is supposed to be providing an example of how to use a module, it doesn't work anymore because the code's changed since it was written. And because people aren't running their doc tests in their continuous integration servers, they don't catch these errors. And it makes sense that they're not because running doc tests, as we saw, is tricky. So it'd be really nice if there was a way to make running doc tests less of a hassle. And that brings us to the package that I want to talk about today, Xdoctest. So Xdoctest is a mostly backwards compatible module. The key features is it has more permissive got-want strings. It uses static parsing to parse out your doc tests, unlike the dynamic parsing of the built-in one. And it has an enhanced runner. The output messages are a little bit better. It has a cleaner CLI. But by far, the most important feature of Xdoctest is it has simpler doc test syntax. Instead of having to prefix your code with either chevrons or dots, depending on if it's a multi-line statement or not, Xdoctest has one rule. Put 3 chevrons in front of everything and be done with it. So how is this possible? Why does the built-in Python doctest module have such syntax restrictions, but Xdoctest doesn't? Well, to understand this, we need to take a quick aside into formal languages. On the left, I have something called the Chomsky hierarchy, which sort of ranks the complexity of languages, both in terms of how expressive they are and how easy it is to ask questions about them. So on the very bottom, we have regular languages, which are the least expressive, but the most easy to ask questions about. Above that, we have context-free languages. Above that still is context sensitive, and at the very top we have recursively enumerable languages, which are equivalent to Turing machines, hence the image of our friend Alan Turing. Now, the Chomsky hierarchy is a simplification of formal languages and automata theory. So on the right I have a more complete version. You can look up on Wikipedia if you are interested in that. But for the purposes of our talk, we really need to understand the regular languages and the context-free languages. So that's the theory. Now let's go into the practice. So where does Python sit on this Chomsky hierarchy? For the purposes of our talk, we're going to classify Python as a context-free language. Now, if you go online, you'll quickly find that Python is not context-free, but this is mainly due to the indentation scoping. And if you were to abstract this away, you would actually get a context-free language. So it's close enough for our purposes. Now, Python has 2 modules that I'm interested in right here. We have the regular expression module, which parses regular languages. And we have the AST module, which parses the Python context-free language. So the issue with the doctest module is that it tries to parse your doc tests using regular expressions. Now, doc tests are just Python code. So it's trying to parse a language that is context-free using a library that is meant for regular languages. So Python is just too complex to be parsed by regular expressions. You can't mathematically do it, which is why in Xdoctest I've replaced the RST module, the regular expression module, with the AST, or abstract syntax tree module. And that's how I extract which lines belong to which statements in Xdoctest. Essentially, doc tests are Python code and we need to treat them as such. So now that we're a little familiar with Xdoctest, let's go back and revisit our case studies. Let's rerun the paragraph doc test. Instead of using the doctest module, we'll use python-m xdoctest. We'll pass it the talk.py file, and additionally, Xdoctest allows you to specify the name of the function which you want to run the doc tests of. So we run this and it works. There's no problem. Xdoctest is able to handle the indentation and prefixing regardless of whether a statement is a multi-line or a single line. Additionally, with multi-line strings, sometimes having those chevron prefixes is a little annoying because the purpose of multi-line strings is you don't have to prefix them with anything. You can just write the text out as you need to. Xdoctest can also handle this case because it parses your doc tests like they're code. It doesn't need to know which line belongs to which statement. So you can actually omit the chevrons for a multi-line statement if you want to, but you don't have to. So now let's revisit case study number 2. If you remember last time, this next iterable line was causing us problems because it returned something and we didn't tell it that we were expecting anything. So let's run python-m xdoctest on the talk.py file, and let's test the function allSame again. Now, this works as well. Xdoctest is built such that by default, if a statement produces a value and you don't give it anything to check, it assumes that you didn't care about checking that value. It will still fail if you provided a want and the thing that you got is different, but in cases where you don't care, it doesn't care either. Again, Xdoctest is flexible. Xdoctest is also easier to run. With the original built-in Doctest module, you can only give it a file path, and it's going to run all of the doc tests that it can find in that file. Xdoctest, on the other hand, you can pass it either a module name or a module path. If the module name or path is a package, it will recursively check all the files in that package for doc tests. You can also give it a command like list all of the doc tests in my package, or run all of the doc tests in my package, or you can pass a specific function or class to run the doc tests of. Even more specifically, if your function or class has multiple doc tests in it, you can use this :index syntax to specify which of the doc tests you want to run. Xdoctest also has better output. If you run Xdoctest on a package or module, any of the doc tests that fail will be listed at the bottom. Not only will they be listed, but they'll be listed in such a way that it gives you a command that you can use to re-execute that failed doc test and perhaps debug it. Xdoctest gives you not only the line number where failures happen with respect to the doc test itself, but where that doc test is in the file. And lastly, we use pigments to colorize the output and make everything just a little bit more readable. Xdoctest has better directives. We talked a little bit about the directives that exist in the built-in Doctest module, specifically the ellipses directive, but it also has a bunch more. Some of them I've found less useful than others, and Xdoctest actually doesn't have these implemented. If you want these, you can send a PR and I'll probably accept it. But in the wild, I really haven't seen these used too often. More interestingly, Xdoctest has some new directives, namely skip, ignore want, and requires. So skip, what that does is that essentially skips the line that you're on, and requires will conditionally skip the line that you're on based on either a command line argument. In this case, this line will not run unless -- show exists on the command line. You can also condition on if a module exists and is importable. In this case, we check to see if the NumPy module exists. Or you can condition on the operating system. And you can look in the documentation for more examples of what conditionals are possible. So let's look at an example of these directives. Something I didn't mention is that in the original Doctest module, directives can only be applied in line. Essentially, you can only put them after a single line of code, and they only apply to that particular line of code. In Xdoctest, it's a little different. If you have a directive and it's the only statement on the line, then that directive is applied to everything below that line. Otherwise, if it's on the same line, it works as it used to. In this case, we have an inline directive, followed by a multi-line directive, followed by another multi-line directive. Notice the minus here instead of the plus. The minus disables the directive, whereas the plus enables it. So if we actually go and we run this doc test using Xdoctest, we see that the Xdoctest prints out the source code for the doc test, and we can see the output that we get. We see this is run because it's the first line and there's no directive applied yet. then the next line is not run. Neither are the next 3 lines, because we've enabled the skip directive. But if we disable the skip directive, the final line does exist. Xdoctest ships with a Pytest plugin. Pytest actually comes with a built-in Doctest plugin by default. But if we pip install Xdoctest and we give Pytest the --xdoctest command line flag, that will tell it to disable its built-in Doctest plugin and enable the Xdoctest plugin. This will add all of your Doctests to your testing suite. So what happens when your Doctests are working? If you use the Xdoctest runner instead of the Pytest one, what happens is that it tells you how many tests it found and how many tests will run. It then shows you the source code of the test that it's about to run, and then it displays the output. And finally, at the end, it tells you how many tests pass versus how many tests there were. So in the more useful case, what happens when Doctests fail? I went over this a little bit before, but let's look at the details. So again, Xdoctest print how many tests are going to run. It prints the source code and the outputs and what the result is. But at the end, it tells you a list of which tests failed. And it tells you a command line that you can put into your shell to reproduce that test. Let's reproduce one of these failing tests here. I'm going to reproduce demo 3. And you can see that it just runs the one test that failed. It again prints out that this is the failed test. And we can debug this to try and fix it. We see that the doctest source is print demo 5, and we pass it a want string of demo 3. So we got demo 5, and then we see that there's a failure. And the reason is a got want exception. So we expected to get demo 3, but we got demo 5, and then it gives us a little bit of a representation difference in the strings, and thus our doc test failed. So we can go and fix that and hopefully make our doc tests work. So that's a basic overview of Xdoctest. It provides an easier way to run your doc tests. I didn't go over everything that it can do. There's some miscellaneous features and some other things I haven't talked about. One miscellaneous feature I'll just quickly touch on is that there is a zero args runner. In the spirit of having entry points everywhere, I've often found myself sort of abusing Xdoctest to run functions that actually don't have doc tests. As long as a function doesn't have any arguments, there's no reason that you can't just run the source code. So Xdoctest has the ability to, if you specify the function explicitly, it will run any function that doesn't have any arguments or any arguments that it can't introspect. There's also a lot of nice utilities in the Xdoctest package. A lot of these utilities have actually made it into my utility package called ubelt. And something I want to highlight is in writing ubelt, I've been able to use Xdoctest to achieve 100% test coverage on the code base. That sort of serves as a testament to how useful doc tests can be. So Xdoctest isn't perfect. There are some limitations. One, it's slightly slower than the original module, but that's mainly because I'm using abstract syntax trees instead of regular expressions, and kind of hard to get around that. But even in that case, there's probably still things that could be done a little bit more efficiently. It's not slow by any means, but it is slower than the built-in Doctest module. The other limitation is it's not 100% backwards compatible. It's mostly there, but we have those directives that are unimplemented, as well as I've tweaked some of the defaults of these directives to essentially be more permissive and make it more likely that a doc test will actually execute without having to cause the programmer too many headaches. So let's wrap up. We've talked about doc tests and how they can be used using the original Doctest module, as well as Xdoctest. And there's some differences between these two. The original Doctest module is built into the standard library. It uses regular expressions to parse the Python code. It has a restrictive syntax. The output is sort of terse and hard to read, and it can only run one file at a time, but it has massive amounts of inertia behind it because it's part of the standard library. On the other hand, we have Xdoctest, which is an external pip installable module that uses abstract syntax trees to correctly parse Python code. It has a more relaxed syntax with better directives and colored, arguably more readable output. It's mostly backwards compatible. It runs quite well on a lot of the existing packages that use Doctest that I've tested it on. It can run either single functions or entire modules, and I've tested Xdoctest on all CPython versions, 2.7 plus, as well as PyPy. But it only has 34 stars on GitHub, despite having 3.4 thousand downloads every month. So if you want to contribute to Xdoctest, you can find it online at github.com/erotemic/Xdoctest. I've shown an image of the README on the right. The main areas for contribution are, again, the parsing could be a little bit faster, as well as the external documentation could be better. It's not terrible. I've actually put a lot of work into it in the past few months, but it could use some eyes that aren't so closely tied to the project. Another contribution is maybe implementing those other directives that I haven't done yet. If you want to build on top of Xdoctest, there's a lot of useful static analysis tools that I've written to make it possible. And I think there's a lot of cool refactoring tools that could be built on top of these utilities. So to conclude, we've learned about doctests, what they are, and why they're awesome. We've talked about the built-in Doctest module with its strengths and weaknesses, as well as the new Xdoctest module with its improvements over the built-in, its limitations, as well as some cool stuff. And if you remember nothing else from this talk, please remember what Chomsky says. Regular expressions are for tokens, abstract syntax trees are for Python code. So please, 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 please do not use regular expressions to attempt to parse Python code. It's mathematically impossible. Now, I'd take questions, but it's a little hard to do that in this format. If you're watching this on YouTube, leave the questions in the comments and I'll do my best to address them. So that's it. That's the end. You can pip install Xdoctest and try it out.